Okay, this last section that we're going to talk about is how to solve a quadratic equation using all the information we've learned before for factoring. Remember that when I think I told you before that when we talk about factoring, we're really trying to find where a parabola, which is a quadratic equation, where it crosses the x-axis. And so when I solve an equation, I can actually find out at which points it's going to cross the x-axis. And that's the goal of solving quadratic equations. For right now, we just want to concentrate on how to solve them. We have this idea that says if I multiply, say, a times b, and I set that equal to 0, then I know that either a is equal to 0 or b is equal to 0, or both are equal to 0. Because the only way to come up with the answer of 0 is to multiply by a 0. So we use this identity or this property here in order to solve our quadratic equations. This first example I'm going to show you in example A. I have two binomials that are either already factored or just started out this way, and they are already set equal to 0. So to solve this, we break this apart into basically two equations. We say x minus 1 is equal to 0 and x plus 4 is equal to 0. Because remember, one of these has to be equal to 0, or both of them have to be equal to 0 to solve. And this is a simple one-step equation at this point, so I find out that when I add 1 to both sides, x is either equal to 1 and x is equal to negative 4. So my answer then is 1 and negative 4. And what that says, we're not going to graph this, but what that says is that this parabola, that is the equation of that when we multiplied it back together, this parabola would cross at 1 and at negative 4 and look, I don't know, something maybe like this. Now we're not interested in that, but that's what we're finding for this. That's why we solve these equations. Okay, let's look at another example. I have two terms being multiplied together. They're both set equal to 0. So we just take them apart and set them equal to 0. Just like that, and then solve each one of these equations. Now this 5x equals 0 is a valid equation. We find out that x is just equal to 0, and over here x is equal to positive 15. So when my answer, at the end of my answer, I would write this as 0, 15, and there's my answer. Over here in letter A, I should have written this as negative 4 and 1, and those were my answers. Okay, let's practice this again. This time in letter G, I do not have a factored trinomial. My trinomial is just a trinomial, and I need to factor this first. So when we factor this, we know it's going to factor into two binomials. I'm going to go ahead and set that equal to 0 because it's already set equal to 0. I know that this is going to be an x and an x. Remember, the second sign tells me that I'm going to have a plus and a minus, and I'm going to subtract. So what are the factors of 30 that subtract to give me negative 1, and that happens to be a negative 6 and a positive 5. So I break these apart into x plus 5 equals 0, x minus 6 equals 0. So here I'm going to subtract 5. Over here I'm going to add 6. So my answer is negative 5 and 6. Most of the time, once you factor your trinomial into the binomials, you have a one-step equation, most of the time. Okay, now this last example over here, or this one that I want to show you now, is letter K. And notice that I have a term equal to something other than 0. I cannot solve this using our identity up here unless my equation is equal to 0. So what I need to do is I first need to subtract 25 so that it is equal to 0. Now I can factor this. Remember, this is a binomial, or two terms, and the first and the last term are both perfect squares. So this is going to factor into x plus 5, x minus 5 equals 0. So I have x plus 5 equals 0, x minus 5 equals 0. That's a 0. Now, x is equal to a negative 5 and a positive 5. So that's how we want to write it. So the key to this one is I cannot set this, I have to be able to, my equation has to be set equal to 0 before I can solve using our identity that we're doing. Okay, so let's practice two more, and then a word problem. So let me give myself a little more room. This time, in this example, I have a trinomial, but I see that this is raised to the third power. Now, we don't know how to solve those equations yet. All of our equations should factor into a quadratic where the highest power here is a 2. So what I'm going to do is I'm going to look at each of my three terms and see if I can factor anything out. And sure enough, I can factor a 4x out of each of these three terms. That leaves me with 6x squared minus x minus 5 equals 0. And now I need to factor this trinomial right here. So I'm going to use the grouping method on this, and I'm going to kind of take up a little bit of room. I'm going to do this in a different color. I know that 6 times 5 is 30. I know that I'm going to subtract. So I want to know, what are the factors of 30 that give me a negative 1? Well, that was negative 6 and a positive 5. So I'm going to rewrite this trinomial as 6x squared minus 6x plus 5x minus 5. And I'm going to group this and factor. So I get 6x times x minus 1 plus a 5 times x minus 1. I'm probably going to need some more room here. So my final factored trinomial is going to be, remember we have a 4x up here, so I have 4x times 6x plus 5 times x minus 1, and all of that is equal to 0, because we have to bring that part down also. So now I took my original trinomial up here, which was 3 terms. I took out the greatest common factor, and then I factored the smaller trinomial to end up with 3 terms down here. I can set each of these 3 terms equal to 0. So I say 4x equals 0, 6x plus 5 equals 0, x minus 1 equals 0. Because this was already equal to 0, I can just go on with my properties here. So in this first equation, I find out that x is equal to 0. In this second one, I find out 6x is negative 5, so x is equal to negative 5/6. And in the last problem, equation, I find out that x is equal to 1. So in other words, I have 3 places it's actually crossing the x-axis. And I'm going to say that x is equal to negative 5/6, 0, and 1. And that's your final answer to this equation on letter B. And let's practice that one more time. Okay, this time I have a binomial times a trinomial. It's all equal to 0. So I'm going to take the first binomial. Actually, I'm going to leave that one. I'm going to factor the second trinomial. Okay? The second trinomial, I'm going to come over here and I'm going to factor this off to the side. I'm going to use grouping. So 10 times 4 is 40. Remember, this second sign tells me to subtract. So what are the factors of 40 that subtract to give me negative 3? Well, I believe that that would be negative 8 and 5. So I'm going to replace 10x squared minus, how about plus 5x minus 8x minus 4. I wanted to pair the 5 with the 10. So now I'm going to group. Don't forget to change your sign. I can factor a 5x out, and I'm left with 2x plus 1 minus 4 times 2x plus 1. Okay, so now I'm going to come back over and I'm going to kind of combine this. I have 9x plus 5 from the original equation. I have a 5x minus 4, and I have a 2x plus 1. All of that is equal to 0. And really, all I've come up with now are just 3 separate equations that I need to solve for x. So the first one is going to be 9x plus 5 equals 0, 5x minus 4 equals 0, and 2x plus 1 equals 0. So, solving for each one, I get x is equal to negative 5/9. Here I get 5x is equal to 4, so x is equal to 4/5. And here I get 2x is negative 1, so x is negative 1/2. So I have 3 possibilities. They're all fractions, but that's certainly okay. So I get negative 5/9, negative 1/2, and 4/5. As long as you get all 3 of those written, that'll be good. Okay? And that's how you solve a quadratic equation with factoring. And we want to do one more problem because quadratic equations can be modeled in lots of different ways. And this is a really good example about dropping something off of a building. Here we have the equation h is equal to negative 16t squared plus 576. So I want to know how many seconds after the rock drops will it hit the ground. Okay, so if I have a building here and I am dropping an object off, dropping a rock, and there it goes down the building. Well, when it hits the ground, kapush, right there, then the height is 0, isn't it? So 0 would be the height if it's on the ground. So what this means is I can take the equation. 0 is negative 16t squared plus 576, and I can factor this and solve. So I'm looking at this 2-term equation here, and I know that I can factor out a negative 16. So let's do that. So I'm going to say 0 is equal to negative 16 times t squared minus 36. And I know that this t squared minus 36 is going to factor into t plus 6, t minus 6. So we can basically divide off this negative 16 or just drop it. It just ends up dropping off. So I'm left with 0 is equal to t plus 6 and 0 is equal to t minus 6. So when I solve for t, here I'm saying t is equal to negative 6 and t is equal to positive 6. Remember that we are looking for seconds. I cannot have a negative 6 for seconds, can I? That doesn't exist. But I can have a positive 6 for seconds. So what I found in this equation is that After 6 seconds, the ball hits the ground. So how many seconds after the rock is dropped will it hit the ground? 6 seconds. Because this answer, t equals -6, doesn't make sense for in context to our equation. So here are some examples of how to solve quadratic equations. I have a worksheet of classwork examples that I'm going to just put the answers, I'm going to work through them and show how I worked all of them if you'd like some extra practice on that. And that's how you work solving quadratic equations using factoring.